All right, so we're ready for step one, improving the Cauchy criterion. And to remind you, the Cauchy criterion says that a sequence is Cauchy if and only if it converges. And so we have to prove two directions, the first of which is the easier of the two. We show that if we have a convergent sequence, the sequence is also Cauchy. So we're going to start off assuming a sub n converges to some capital L, and then we're going to try to figure out how we can use that to show the sequence is Cauchy. So let's start like many of our proofs. Let epsilon be bigger than 0, and consider the thing we want to make small. So in this case, what we're trying to show we can make small is the difference between terms in the sequence. Now we're going to use another familiar trick. Once we're here, since we know the sequence converges, I'm going to add and subtract the limit inside the absolute value. So this is our trick where we add a clever form of 0, so we don't change the value of the expression. And then we, as my advisor would say, crash through with the absolute values and use the triangle inequality to split this into two pieces. That's not too good. So this then, I'm just going to emphasize we can rewrite as am minus L, and then the absolute value of L minus an is the same as an minus L. Having trouble with my m's. Okay. So now I think we can kind of see how the proof is going to finish up. Right, when we split something up like this, what we want is to make each of these pieces less than epsilon over 2, because what we want to have happen is to have the full result be less than epsilon. Right, well, it's not too much trouble to make each of these less than epsilon over 2 because the sequence converges to L, so we know we can do that. So since an converges to L, we know there's a capital N. So epsilon, denoting epsilon over 2, such that if m is bigger than capital N's of epsilon over 2, a sub m minus L is less than epsilon over 2. And it's also the case that if little n is bigger than capital N, then the second piece is also less than epsilon over 2, right? The requirement is for any index past capital N, we'll get the difference that we need. All right, so then we're basically done. With m and n bigger than capital N, we have a sub n minus L, a sub n minus L, epsilon over 2 plus epsilon over 2 equals epsilon. And so our a sub m minus a sub n is less than epsilon as required. And that should do it.